All right, so this is our first day of factoring, and the first thing of factoring is GCF. So when we're doing factoring a couple weeks from now, and we come back from break, we will always look for GCF first. Okay, so remember this. So GCF first always. So what factoring is, though, is taking a given polynomial expression and then rewriting it as two different ones, reduced ones that are multiplying. So we'll be given any kind of polynomial. Usually it'll be three terms, a trinomial or a binomial, two terms. And we'll look to factor it. That means rewrite it as an equivalence expression, but instead of one polynomial, it'll be two of them. And we'll call these factors. So we'll have two things that will multiply back to the original. So one way to factor is looking for a GCF, and don't forget GCF is a greatest common factor. If you chose just a common factor, you would have to keep factoring until you run out of common factors. So it's always best to start with the greatest common factor, just like reducing fractions. So the GCF you'll be looking for is the largest single term expression. And what is a single term expression called? A monomial. So you'll be looking for a monomial that can divide in evenly into all terms. So our GCFs will be built from two different things, numbers and variables. The first thing you want to do is find the GCF of the numbers. So again, start by listing all your numbers, your coefficients and constants, and then find the GCF of those numbers. That's the first part of your GCF. Then look for a variable. So after you identify that smallest power variable, you're going to put that together with the GCF of the numbers. So your final GCF will be the GCF of the numbers, and you're going to multiply times the GCF of the variables, which is the smallest power variable. So sometimes you could have a GCF that is just numbers, just like number 5, okay? Sometimes it will be just a variable that comes out. Only a variable could be divided evenly through all terms. But sometimes it will be a combination of two things here, a number times a variable. All right, using our flow chart from the previous page, we are going to find the GCF here and then use it to write the factored form. We're going to rewrite that polynomial as two things that are multiplying. First is find the GCF. All right, so remember, we're going to be doing the GCF in two different places, the numbers and the variables. Let's take care of the numbers first. So looking at the numbers here, we have 6, 2, and 8. So let's make a list of those numbers. So 6 can be made from what pairs that multiply? 1 and 6 and 2 and 3. Those are the only factors that make 6. What about 2? Just 1 and 2. Just 1 and 2. And the last number up there is 8. What multiplies to make 8? 1, 8, 2 and 4. 2 and 4. Now, in that list of numbers, what's the greatest common one?
4. 1.
You might think 4, but it's only here. Okay. 2 is in all three lists. It has to be in all three terms. So go ahead and circle 2. So that's part of our GCF. That's the first part of it, the first half of it, 2. Now we're going to look at the variables. We have x to the third, x squared, and x to the 1. Which one's the smallest power up here? X to the 1. That's going to be part of our GCF. So 2 times x. Now to write it factored form, we're going to divide each term by the GCF. So 6x to the third divided by 2x. What does that equal? 3x to the second, 3x squared. Okay. Next one, 2x squared divided by our GCF of 2x equals x. And now our last term, take the negative on this one. Our last term is negative 8 divided by our GCF of 2x. What does that equal?
Negative 4.
Oh, we got to put the x on the negative 8x there. Sorry. What's that equal? Negative 4. So we're going to rewrite this inside parentheses altogether. So 3x squared plus x minus 4. That is one of the parts that make the original. What's the other thing we have to multiply by? The GCF. 2x. Now that is factored. We're going to call that factored form. Okay, we just took the original expression here, the trinomial, and we factored it using a GCF. So this is a monomial times a trinomial that would be equivalent to what we started with up here. All right, try out these 4 problems. 2 of these are going to be GCFs of just numbers. One of them will be just a variable, and another one's going to be a combination of a number and a variable. Don't forget, you're not just finding the GCF, but you're also writing the factored form. For 36 and 24, list out those pairs. And after you list those pairs, find the biggest number in there. Eventually, you'll be able to hopefully do this part in your head. Okay, finding that biggest number in your head. If not, always list them out if you can't find them in your head. So the 12, is the biggest number in both of those lists. So we're going to take out a 12 here. My GCF is equal to 12. What about my variables? There's no variable term here, so we can't have a variable in our GCF. They both have to have a variable. So GCF is only 12 in this case. So that's the first part of our answer. Now we rewrite it in factored form. That means 12, the GCF, times another part, another factor here. So divide each of those by 12. So 36 divided by 12 is 3y. 24 divided by 12, negative 2. That's the factored form answer right there. All right, so for number 2 here, we are looking for a GCF. We're actually going to have a number and a variable for this one. So looking at our numbers, we have 4, 6, and 10. Always check if the smallest one can fit into the others, but this one cannot. 4 does not divide in evenly to 6 or 10. So what's the next biggest number that makes 4 is 2 times 2. So 2 is a common factor of all 3. It's actually the greatest common factor of the numbers, or our constants, or our coefficients. So 2. And now look at the variables. We do have a variable term in all of them. So we're going to take our smallest variable power, that's x squared. Since x squared can fit into all the other ones, that's our part of our GCF. Now we're going to write the factored form by dividing each of these terms by 2x squared. To start writing our factored form, we always have to have our GCF first. So 2x squared, that's our first factor of this polynomial. And we're multiplying against the reduced one here. So we're going to divide each of those by 2x squared. So 4 divided by 2 will be 2 inside. And then x to the 5th divided by x squared. We'll have 3 copies of x left. Another way of thinking about doing this is, what times 2x squared will make negative 6x to the 3rd? So 2 times negative 3 would make that. And then x will make that x to the 3rd. Our last one there, 10 divided by 2 is 5. And then x squared divided by x squared is just going to go away. So there's our final factored polynomial for that question. All right, down here at number 3, we're looking at the constants and the coefficients. So we have 15 coefficient, a 10 coefficient, and a 5 constant. So we notice that there's no variables here on the last term, so we're not going to have a variable in our GCF, but we do have a common factor of 5 between all the numbers. So our GCF will be just the number 5. And now we're going to write the factored form. So 5, our GCF, times each of those reduced by 5. So 15 divided by 5 is 3. We still have t squared. And then that becomes 2t, because 5 times 2 will give us 10. And then the last one will be minus 1, because that'll be 5 times negative 1 to get negative 5 there. So there's our factored polynomial. Let's go over to our last problem here, number 4. This one's kind of tricky because you might be tempted to take 4 for your GCF. But notice, not all of them have a factor of 4. 4 can go to itself, can go into 8, but this coefficient is 1, so we cannot take a number out, a common factor. It has to be all 3 have common factor. So no number for our GCF, but they do all have a variable term. So we will be taking out the smallest power variable, that's x. So our GCF is only x in this one. So factored form, x GCF times, and now we're going to reduce or divide each of those by x. So we'll have x squared minus 8x plus 4. May the math be with you.